Hi, I'm Pierre Morales and welcome back to this series of videos where together we learn how to code in Solidity. Today we have a similar one as last time, but this time we're looking at the keyword block and the functionalities that come with it and that it unlocks, as well as what we can do with it. So the first example that we have, the first functionality that we have is the one that we've already looked at together when we're doing our video on time. And it's block.timestamp. So this one returns the current block's timestamp. And the timestamp is actually using the epoch time. So for those that do not know, the epoch time is it's an integer that is the sum of every second since this epoch time, which is January 1st, 1970. It's a fairly standard unit in the computer science world. And the current time is about 1.6 billion seconds since that time. You can use it in order to schedule certain functions, schedule certain functionalities from your application through these smart contracts. And we've used it in a couple ways. We've used it in order to create an auction, as well as automatically change the level of players in our game. After that, we have a block.chainID. So this returns an integer, which is just the current blockchain ID. And it's used to confirm the use of the intended blockchain, not a fork. And it came when Ethereum Classic was forked. So for those of you that don't necessarily know, Ethereum is one blockchain that has been forked more than once, in fact. And anyone is able of creating a fork, which essentially is a copy of the blockchain that starts, that basically splits from the original blockchain the moment the fork happens. And from that point, they will have separate IDs. This block.chainID allows us to simply verify what ID we're working on. Ethereum has the ID of 1. Now, how can this be useful? If you have a software running on a node, and this is the node that is running all of the transactions for you directly, which is often the case if you use a wallet, usually it's going to use their node in order to communicate with the blockchain. Then if ever they change whatever chain that they're actually looking at, well, then this can impact you, and they can do this without you knowing about it. So maybe you would be able to verify that, and this you would do it using block.chainID. Then we have block.coinbase, and this one returns an address, the object address, data type address, should I say, and it returns the address of the current block's miner. And this way, it allows you to simply retrieve this information, use it in whatever way you want. Maybe you have certain contracts that would trigger if it would be your address. Imagine you're a miner. And it can also be used in general if you would want to build a blockchain explorer. Then obviously one of the data points that you need to display for a particular block, transaction, etc. would be the current block's miner address. Then we have the gas limit. So this returns an integer, and it returns the current block gas limit, which is the maximum sum of gas fees for the block. So when you have an Ethereum transaction, then every time you pay a certain fee, which is called gas. Now, in one block, there is a maximum amount of gas fees that can be paid. Why is that? Well, if there wasn't a maximum, then we would be able to have an unlimited amount of transactions. This gas limit allows us to know when is the limit for this block. Enough transactions have happened, certain amount of gas has been paid, therefore the block is finished, and it can go through the verification, and we start the next block. And it can be useful. It can protect the node from attackers who can make an effective infinite transaction loop. If some person with bad interest would create an infinite transaction loop, then there would be no end to the block. gas limits is here to control that. You can also set actually a gas limit for your contracts, but we'll see this later. And it's not exactly done through this functionality here. Then we have the block number, which returns quite simply an integer, which is the block number. And this is a value that can also be used as a timestamp, because obviously we know that every X amount of time there is a new block that is being produced. This is a fact that will never change, just like seconds will pass. Well, the block number is something that can be used for example, if you have a release, then it will only happen at a certain block, and you're capable of estimating when this block will happen, so it allows you to organize your time. If you think of new updates that happen on the Ethereum blockchain, it's always at a certain block number, not at a timestamp. Then we have block.difficulty. So this returns an integer, which is the current block difficulty. So for those that do not know, when working with blockchains like Ethereum or even Bitcoin, they have a certain difficulty that is set to the miners. So what it means is that it is easier or harder to mine a certain block. And this is very important because if we have too many miners all of a sudden, then it is too easy to mine the block. Therefore, it could be mined too quickly. So the difficulty has to be adjusted and has to be increased so that it is in fact at the same level for all miners, just as difficult to mine this block. The opposite is also true. If we have too little miners, then it is too difficult and it would take too much effort, too much time to mine a particular block, in which case the difficulty is adjusted and it's adjusted to the downside. In terms of actual utility for this block difficulty, of course, if you are, somehow you're a miner yourself and you're automating your mining rig based on this block difficulty, you have smart contracts that are somehow linked to that, maybe in automatically selling, this kind of application is possible. Otherwise, when searching online, the true utility that I seem to have found is this block.difficulty, this number that results from it, is often used for finding random numbers, because unlike many other programming languages, Solidity does not have a random function that allows you to just create a random number. Now, on top of that, we have a couple bonus. They are not directly linked to block, but they are functions themselves. The first one is block hash, which returns the hash of the current block. So the hash, what's the hash of the current block? Well, if you think of a transaction and the way it is recorded on the blockchain, it's also a hash. And this hash is the address where the coin is sent from, the address this coin is sent to, and whatever amount it was. This basically creates the hash. And a block is a list of transactions, so it's a list of hashes. And a block also has a hash, which is the hash of all of these hashes. And you can get this function you can get this value by using the function block hash. Also, there is the function gas left that returns the gas left for the current transaction or contract. And this you can use in order to count how much gas has been used as part of your smart contract, how much gas you have left still to be used. And this can be very useful when working with adjustable gas levels, because of course the way the blockchain works is that if you were to pay a higher gas fee, then your transaction would be taken into account and higher priority, therefore could be verified before the others. So that's it for today's video. We've looked at all of the components that are inside of this block keyword and how we can use them for different smart contracts and how you can build your applications. Well, of course, in the next videos, when we're going to get back into some coding, we're going to look at how we can use them based on the use cases that we'll be working on. In the meantime, take care, and I'll talk to you in the next video.